On page 52 is Cumulative Frequency Curves is the title. And like I said, this is the second half of today's lesson. We are going to now kind of switch gears away from measures of central tendency, and we're going to be talking about the graphs and interpreting information of cumulative frequency curves. Okay? Just the part that's above the black line is actually going to go on the notebook pages of your notebook, but everything else is going to be in the foldable. Okay? Make sure you guys that you are following along with me, not writing ahead or anything like that. Please make sure that you're following along. Okay? A cumulative frequency curve is a way to represent your data. Just like a histogram was, a cumulative frequency curve is another way to represent your data. Okay? There will be times where you will be asked to draw a cumulative frequency curve, and the steps are as follows. To draw your cumulative frequency curve, you're going to actually need to take the table that's given to you, and you're going to need to construct a cumulative frequency table with upper boundaries of each class in one column, and then corresponding cumulative frequencies in another. Okay? Now, we did upper boundaries in the histogram video. Okay, remember when you guys were having to draw your bars for your histograms? Remember you took the upper bound of one class and you took the lower bound of the following class and did the average? You're going to also need to do that for your cumulative frequency curves. Okay? And then to find your cumulative frequency, what does cumulative mean? Altogether. Okay? Your tables are going to be, sometimes it'll be the cumulative frequency, sometimes it'll be a normal frequency. And so to create your cumulative frequency table, you're going to actually have to continue to add the frequencies to each other. So it's going to be you're adding all the frequencies up eventually. Okay? After you get your table, you're going to make your actual graph. You need to label your axes. Whether it's a histogram or cumulative frequency curve or box and whisker or anything else that we do, you need to label. X-axis is your upper class boundaries. Your y-axis is your cumulative frequencies. Once you get the labeling done, then you plot your points, okay? And literally, because you'll have the table already there, it's almost like, okay, here's the X, here's the Y plotted, X, Y plotted. But what you need to know is that the beginning of the curve is at the lower boundary of the first class, and the end is at the upper boundary of the last class, okay? So we are about to draw our first cumulative frequency curve. All right, so flip over the foldable. We got our first example here, okay? It's talking about a supermarket. It's open 24 hours a day, and it is monitoring the number of parked cars each hour. It's monitored over several days. The results are shown in the table. We're going to organize this information into a cumulative frequency table, and then we're going to draw and graph the cumulative frequency curve. Again, this will not be given to you. Like the two columns where you actually have to lay everything out. No, this is just for the first one so you understand what's going on. Sometimes they'll have a blank table for cumulative frequency and you'll have to fill that in yourself, but you won't have this upper boundary one. I have not seen a question where they have the upper boundaries. But you do need them to graph it. So, just to refresh your memory from the histogram video, to find the upper boundary of the first class, you take the upper limit of the first class and the lower limit of the second class and do the midpoint. What's the midpoint between 49 and 50? 49.5. If you're unsure of where that number came from, just do 49 plus 50 divided by 2. You're just finding the average. The second class, you're going to take 99 and 100 and find the midpoint, which is 99.5. And yes, it does continue on like this. What's the next class? 149.5. What about the fourth class? 199.5. And it just continues like that. The next one is 249.5. The one after that is 299.5. The one after that. And the last one. Again, we are taking the upper bound of the class and then the lower bound of the following class. Now, the upper class is 399. If this were to keep going, what would be the lower bound of the next class?
400.
And that's why we were able to get 399.5, just in case anybody didn't understand that from the histogram video. We're good? So far, so good? We're pretty easy? Cumulative frequencies. Cumulative, that's everything added up. Like your cumulative GPA is taken from your freshman year and your sophomore year, and it's added into your junior year, and then they do all the calculations to find it. Same concept. But we all started out with that first semester of freshman year, correct? First semester of freshman year is that very first entry. So the cumulative frequency for the first class is that first entry that we started with, the 6. But then, when we had second semester freshman year, then we take both of them, added them together, and did whatever to them. Same concept. You take the 6 and the 23, and you add them together to get what? 29. And so then that is the frequency that goes along with the second class, with that 99.5. And you continue that process. You take the 29 and you add it to 41 to get 70. And you just continue that process. At this point, I'm going to stop doing the adding on the side. Because hopefully, does everybody understand how we're getting those cumulative frequencies? What's 70 plus 42?
112.
What's 112 plus 30? Finish off the rest of the table. What's the 6th cumulative frequency? 166. The one after that?
175.
And the last one?
180.
180. Now, one way to make sure that you did good, if you added up your frequencies, this total should equal the last one that you have. If it doesn't, that means you missed a number of adding of some sort somewhere. Okay? That's how you can always check. Questions on how we got our table? Then let's do step 2, where we actually got to make our cumulative frequency. Okay? Of course, we need our X and Y axis. We are going to need to label these bad boys. What's going to go on my x-axis? My x-axis. The number of cars that were parked. Very good. What's going to go on my y-axis? Careful. In a histogram, frequencies go on the y-axis. But in a cumulative frequency curve, it's actually your cumulative frequencies. All right? Yes, this is going to be 0. But how should we label our bottom, our x-axis? This is centimeter paper, so every 5 lines is 1 centimeter. I hear 5s, I hear 50s. If you look at your data, your x's have to go all the way up to basically 399. So how can we fit this on this particular graph?
Well, the big line.
Big lines be 50. Let's see, 50, 100, 150, 200. Does it fit?
Yeah, that works.
Sure does, because the highest one we're going to go up to is actually 399.5, so it actually works perfectly. But what about our cumulative frequency? What's our highest cumulative frequency? 180. So we at least have to cover up to 180. How should we do this? The y-axis. If we do by 50s, that means each little line in between will be 10. So you got 50, 100, 150, and yep, that'll be enough to fit. So that works. Especially if they give you a grid, you don't want to go outside of it. Especially if it's me giving you a grid, because I'm actually looking at the key and the grid I give you to make sure that you can fit it nicely. All right? Now let's plot. You start with your lower boundary of your first class. The first class was from 0 to 49. What's your lower boundary? 0. It's not going to be a negative 0.5. We can't go that deep. So it's going to be at 0. So we're going to start at 0, 0. And then we're going to end at the upper bound value. So that's where we're going to end. So from here, all we do is plot our points. 49.5 and 6. 49.5 is very close to 50, if not almost lying on 50, right? And then we're going to be at 6, which is going to be before that first line going horizontally. The next one is 99.5 and 29. 99.5 is really close to 100. 29 is right below 30.
Oh, shoot.
Does everybody follow me what I'm doing? Mm-hmm. The next one is 149.5 and 70. 149.5 is really close to 50. 70 is actually on the line, 2 lines above 50. Can you guys plot the rest so I don't have to keep flipping back and forth? Okay. You guys get your points plotted?
No. I got lost.
Once you get your points plotted, it's going to be so crucial for you to draw a smooth curve that connects those points. It should be a smooth curve that connects those points. And do your best to make it one solid curve that connects those points. Not like a double line or anything like that. A solid line that connects all those points. And there's your cumulative frequency curve. There it is. Now, do realize that, with this, you always want to make sure that you plot your points accurately, and you do draw a smooth curve, one solid curve. Don't go back over it, trace it the second time, because then that could potentially mess you up. And whatever interpreting you have to do, you base it off of the graph that you draw. Just make sure that it is the cumulative frequencies and not the regular frequencies. Everybody get me? So, the interpreting that I was referring to is stuff like this. Flip over. Cumulative frequency curves are used to estimate percentiles and quartiles and things of that nature. The lower quartile is like the bottom 25%. Okay? So the 25th percentile. The median is the 50th percentile, so smack dab in the middle. And then the upper quartile is the 75th percentile. That's how they correspond. For those who've taken the SAT or the PSAT, once you got your scores back and they said that you were in, the 50th percentile, the 51st percentile, that means you did better than 51% of the people who took it that particular time around. If you were higher than that, then that's really good. That means you did better than that many people. Or not that many people, that much as a percentage. Okay? That's pretty much how it goes, because quartile separated into quarters, percentile separates things into hundreds, but that's how they correspond together. Okay? How do you find each of these things? The lower quartile, also known as Q1, can be found by using the formula n plus 1 divided by 4, where n represents the total frequency, and the value you get when you do n plus 1 divided by 4 is the value that corresponds to your cumulative frequency axis. Okay? So, if n represents your total frequency, take that last example that we just did, the one about the parked cars. What was our total frequency in that problem? 180. So if I asked you to find the Q1, aka the lower quartile, you will plug 180 into that formula. So it'll be 180 plus 1 divided by 4. What is that? What's 180 plus 1, or 181, divided by 4? 45.25. That does not represent your lower quartile. It shows you where to look on your cumulative frequency curve to find Q1. Okay? That's what this part means. Okay? So it corresponds to that value on the cumulative frequency axis. So how do you find it? You take 45.25, you go back to your curve, and this is what you do. 45.25, that's about halfway in between 40 and 50, right? What we're going to do is you draw a horizontal line, actually that's off, at about 45.25 to see where it hits your curve. And then from there, you drop down a perpendicular line to where it hits your x-axis. And then this value, whatever that x value is, course is your Q1. Does everybody understand that?
So it tells you the frequency, the cumulative frequency, so you can find the Q1.
Exactly. So it tells you basically where to look on your graph to find your Q1. Your Q1, your median, your upper quartile, those are always going to be your x-axis values. But that number that you find is a number that tells you where to look on your curve. Now, because we hand drew this, our numbers are probably not going to match. Like right now, mine looks like it's going to be about 120. So I would write down 120 because that's how it corresponds to my graph. But yours might be like more like 125, maybe 130, maybe 115. And the graders know that. So in the mark scheme, it's going to say, give or take maybe 5, maybe 7 units on both sides, okay? Because they know that we're not perfect drawers. But we should fall somewhere within about 14 numbers. If they give you a cumulative frequency curve, though, the window is going to be a lot smaller. I'm talking like give or take 1 or 2, maybe even 0.5, okay? So make sure our curves are drawn kind of nicely. So my Q1, again, it's not 45.25. It was the 120, the value on the x-axis. Does everybody understand that? Okay. The median. The formula is n plus 1 divided by 2. The median doesn't have like a symbol or notation like how Q1 does, like how the lower quartile does. So it literally is just the median, or MED. Okay? Let's take our last example. What was the total frequency? 180. So 180. We're going to do 180 plus 1. Divide that by 2. 90.5. Is that my median? No. That tells you where to look on your curve to find your median. So what do? You go back to your curve. You go to 90.5, which is really close to the 90 mark. See where it hits your curve. And then drop down a perpendicular line to see where it hits your x-axis. Then that value is your median. Is everybody following along? Okay, so in my curve, that looks to be about 170. Yours may be 175, 165. It depends on your curve. The key thing is your curve. So if you jack up your curve, as long as you use your curve to figure this out, you can get your follow-through points. Okay? But for me, it was 170. So my median was 170. Are we okay? All right. And Q3 is your upper quartile. That corresponds to, again, the 75th percentile. That formula is 3 times n plus 1 divided by 4. And again, it corresponds to the spot on your cumulative frequency axis. Somebody do this real quick. 135.
135.
So 135.75, that is not my Q3. That tells me where I need to look on my y-axis to find Q3. So I go back to my curve again. I go to 135.75, which is between 130 and 145. See where it hits the curve. Mine's slightly slanted. Drop down a perpendicular. It won't always be a whole number, guys, but base it off of where that perpendicular line is. And that's my Q3. So for me, it would be about 230. Yours may be a little bit different. It's all based off of your curve. All right, so to find the percentiles, which is usually represent, p percent, some value, and it corresponds to the formula p n plus 1 divided by 100 on the cumulative frequency axis. So these are the types of questions where they'll ask you, okay, well, what is 80% of the students, 80% of the people who parked their car was between, this amount or something like that. Well, 80 would represent your p-value. And so you would plug it into that formula. 80, you would use your total frequency, add 1, and then divide it by 100. And then that value would be the value that corresponds to the point on your cumulative frequency axis. So when I multiply this, the top, and then divide by 100, that corresponds to 144.8. So again, this number does not tell me that, A, that's the answer. It tells me where to look on my cumulative frequency curve. So we go back to our curve, we draw a horizontal line over, and then we see where it hits our curve. So I'm going to use the blue color, and it was 144 point something, so about 144, so that's halfway in the middle. Oh. $144. I see where it hits my curve. And then I drop down a perpendicular. And then that is the value. The x-axis is the value that it corresponds to. Okay, that number would be the 80%. So in this case, it would be about 250. So to go along with this problem, 250 parked cars would be 80% of your data in that case. All right, so every single one of these corresponds to a point on your cumulative frequency axis that you have to see where it hits the curve and then the corresponding x value. And it's the x value that's the answer. The x values are always your answers in these particular cases. Last thing we need to go over.
Miss Poker, Miss Spear, and Miss.
The last thing is going to be your interquartile range, IQR, and to find that you subtract the lower quartile from your upper quartile, okay? And it literally is Q3 minus Q1. So the Q3 that I found for my particular curve was 230, and then my Q1 was 120. So it's the actual x values that you found by, using the formula, going to your y-axis, seeing where it hits your curve. It's the actual x values that you're going to subtract. And when I subtract this, this gives me 110. Now, the interquartile range basically tells me that 110 pieces of my data actually lie within the interquartile range, which is the middle 50%. The middle 50% of my data is going to lie in between 120 and 230, which is about 110 parked cars. And that's how we interpret cumulative frequency curves. So again, your homework is to do these last examples here. All of these examples that were in your foldable. And you are going to be drawing a lot of cumulative frequency curves so you guys can get the practice. And if you have any questions, please make sure you bring them to class the next time.